Hello class, welcome to our lesson today from section 4.5. This deals with the complements and conditional probability rules when we use the multiplication aspects of probability. So we're going to go through some example questions of that. I also have a few odds questions just to make sure we reinforce the idea of odds to get ready for your upcoming test. First thing we're going to look at is a bag of tiles. So there's one tile for each number from 1 to 50. So when you're looking at this, we're trying to find a multiple of 5. So I wrote down all the multiples of 5 here, but you could also just take 50 divided by 5 and you get 10 of the numbers. So the probability that you win would be 10 out of those 50 numbers, which would always simplify down. Okay, and you want to do that on all your questions, and that becomes 1/5. The odds against winning. Okay, so what you want to look at here is there's 10 ways to win out of the 50, or 1/5 of the ways. There's 4/5 of the ways to lose then. So odds against are always losing to winning. And essentially what happens here is you simplify it down a little bit and it becomes a 4-to-1 ratio because the denominators are always going to cancel out. A good indicator if you're on the right track on some of those questions is if you make sure to add 4 and 1 together, it should be the denominator of 5, which was our simplified denominator for the probability of winning. Now let's look at the payoff odds. This says that the company is going to give a 3-to-1 payoff odds. Okay, so that means $3 profit for every $1 put in. How much profit would you make if you bet 16 and win? So that would be 3 over 1 equals x over 16. You just cross multiply it and you get x equals $48. Now that number should always be a little bit lower compared to what it should have been in theory. So if the payoff odds were the actual odds against winning, which would be 4-to-1, okay, if you cross multiply that, you'll get $64. So what you want to look at here is the difference of what the company offers you, which would be a little bit less, versus what you should get, which is a little bit more. Either way, you should also don't forget that if you ask how much money do you get back, you would actually get 48 plus your 16 or 64 plus your original 16 because it's how much you put in plus your profit. Okay, so don't forget that the wording of a question might be a little different as you're going through. Okay, a lot of what we're going to talk about today is the idea of at least one. At least one probability means one or more. At least one is the complement of getting nothing. Okay, so typically when you see at least one of something in probability, it's always found by doing 1 minus the probability of none of them. Okay, so in most of these situations, you're going to be using this idea, find the probability that it doesn't work for any of it, and then do 1 minus it to find the answer. And that's how you'll find at least one in terms of probability in this section. So let's say I toss a coin 5 times. So find the probability you get all 5 heads. So if I toss the coin, these are independent events, so it'd be 1/2 times a half, etc., 5 times, which is 1/2 to the 5th. In most cases like this scenario, you're probably just going to leave that as a fraction 1 over 32. So that's how you would find probability of getting heads every time on the 5 tosses. If you want the probability of getting at least one tail would always be found by doing 1 minus the probability of its complement, which is no tails. And so if you have the probability of no tails, in a heads-tails situation, the probability of no tails is the same as the probability of all heads. So that would be 1 minus 1 over 32. And if you take 1 minus 1 over 32 and find a common denominator of 32, you end up with 31 out of the 32. Okay, anytime you have at least one scenarios, it's probably easier to find the probability of its complement, which is the probability of none, and then subtract it from 1. This question here on the right says find the probability of 3 heads, 2 tails. That question becomes much more challenging. Okay, because you have to deal with the order of the 3 heads and the 2 tails. Okay, we're not to that point yet. Some of section 4.6 will look at some of that. But when you're looking at this section in chapter 4, it's going to mainly focus on none and at least one for the complement idea. So this one says a probability a car is defective when it leaves the factory is 0.0004. So they sell the car, or they build the car, they send it off to the dealership. The probability that it has a defect in it is 0.0004. A car dealer plans to sell 50 of those cars. Okay, so they're planning to sell 50 at the car dealership. Find the probability at least one is defective. Okay, the company would want to know, like, hey, what kind of defects are we going to be dealing with that we have to look out for? So the probability of at least one defective would be 1 minus the probability that none are defective. Now, the probability that none of the cars are defective, okay, these are all independent. Okay, so the first car being not defective is not this 0.0004. it's its complement of 0.9996, because if it is defective, it's 0.0004, but I want that it's not defective, so I have to do 1 minus that. So it's kind of like a double complement idea, which is kind of confusing. But what you want to think about is I want the probability that they're not defective, which would be the 0.9996 number raised to the 50th. I take 1 minus that on my calculator, I get 0.0198. So there's just under 2% chance that I'm going to sell a defective car. So should the car dealership worry about it being defective? Probably not. That's why they offer warranties for so long after you purchase the vehicle, and hopefully they can find the defect. Now, if it's some larger defect that you see, like airbags, for example, sometimes, or there's some brake issue on a type of car, that's when recalls happen, and all the cars are sent in from to the dealership because the company realizes there's a bigger mistake. But when you're looking at these situations, what you want to look at is to make sure that you're finding the probabilities correctly and then raising to a power because they're independent events. And again, this 1 minus idea is used multiple times in this question in order to find its answer. Conditional probability we talked a little bit about when we did independent and dependent events. Remember, this line right here says find the probability of event B given that event A has occurred. There's two ways that you can show this. Your book probably focuses more on this mathematical principle of A and B divided by probability of A. I think it might be easier to figure out just the number of ways for that event to happen and then divide by the sample size of A. And I think you'll see what that means here in these next couple slides. It's up to you which option you pick. I'm going to focus more on the second way because I think it's easier to understand long term, and at least for students that haven't seen a lot of conditional probability before. So let's go ahead and get started with that type of version of conditional probability. Next thing that we're going to look at is drawing 2 cards without replacement from a standard deck. Find the probability that the second is an ace given the first is a king. So when we're looking at this situation, what we want to try to find the probability that the first one is a king, then the second one is an ace. So the first one being a king would be 4 out of 52. Now you could simplify that down to 1 to 13. I'm going to leave them as 52 right now just so we can see where the numbers are coming from. Now, the first one is a king, and I put it off to the side. That means I only have 51 cards left in the deck, and the question is, well, how many are aces still in the deck? And that would be 4 out of 51. You multiply across and simplify if you can. Check those things out with your calculator and see if you get 4 out of 663, or you may have to write it as a decimal. Remember, as a decimal, you're going 3 significant digits, so wherever the zeros are, and then 3 numbers after that for any of these scenarios in general as you're looking at them. Probably the second card is red if the first card is black, so the probability the first card is a black card would be 26 out of 52. Times, I took one of the cards, only one, out of the deck, so there's 51, but there's still 26 red cards because the first one I picked was not a red card. I multiply that together, I get 13 out of 51. The last one says second is a face card given the first is a queen. So we find the probability the first card is a queen. There's 4 queens in the deck, so 4 out of 52. Times, now this is out of 51 again because I took one card out, but there were 12 face cards. Remember, jacks, queens, kings are all face cards, but one of them I already drew in the last in the first drawing, which was one of the queens. So I've got 11 out of the 51 left, and I multiply across and find 11 out of 663. Remember, you want a simplified fraction or a decimal rounded to whatever it says for those situations, or 3 significant digits depending on the scenario. Okay, the next question is just dealing with a table format of just tossing a coin. So this information is just tossing a penny, and then I have some info, nickel, dime, and quarter. The first step to this question is always, any table question is to find the total. Okay, so you add them all up and find the total. That would be the first step. And then you want the probability that you tossed a quarter. So you just add up the quarter column, which would be these two, which would be 40 out of 100, and then simplify. Tails or dimes, remember, that's the kind of Venn diagram looking thing. So if I'm going through this, I'm going to add up all the tails. So add up all these pieces, and then add up the one missing dimes one. You could also, your book's going to say to find the probability of the first plus the probability of the second, and then minus its intersection. Okay, if you're going to go that route, you'd add up all the tails, add up all the dimes, and then subtract 10 out of it because it was double counted. Either way, you should get 61 out of the 100. Remember, this tick mark here means the complement or prime. Okay, that could be used as C, it could be the line over it, or the apostrophe or one tick mark. So that means not getting a heads on the toss, which means you got tails. So I just add up all the tail tosses, and that's how I got that 46 out of 100 number, and then simplify. The last question is a little confusing because of the way it's set up. So it says tossed a penny or not a nickel. Now, essentially, the penny group is covered by the not nickel, so all you have to do is figure out which ones aren't nickels. So just take the 20 out of the nickel category, and you're left with 80 out of the 100, or 4/5. So when you're looking at those situations, that's something you want to think about, is when you have the or statements or union, okay, you want to make sure that you're doing the two groups separately and then combine them together. If they're not mutually exclusive, if there's some overlap, then you got to subtract the double count, or just make sure you only count it once as you're moving forward in the table. The next question says, find the probability you tossed a quarter given that it's a penny, and that's impossible. Okay, there's no way you tossed a quarter if you tossed the penny. Find the probability you tossed heads given it's a dime. So here's the key here. You're looking for this group only. So you go to the dime category, which is this third column. Okay, you add those up, and that's 20. And of those 20, how many are heads? And there's 10 out of the 20, or 1/2. The other thing with conditional probabilities, the order that things are placed does matter. So if you look at the two options on the right side, they look to be the same. They're just inverted order. So the first one is find the probability you got tails given that it's a nickel. So I go to the nickel category. Okay, there's 20 of them. Okay, and of the 20, 12 of them are tails. So that would be 12 out of 20, or 3/5. And then given that it's a tail, if you're trying to look for a nickel. So that just flip-flops the order. But if you're given tail, that's only the 46 tails. That's the second row. And so when you're looking at the second row, okay, that's how many versions of tails were tossed. And then the 12 out of the 46 would be nickels given that it's tails. So it's always given the second piece. That will dictate which part of the column or part of the row you're looking at in order to find the answer. Also notice I simplified all my fractions, or left them, or you could find them as a decimal depending on the situation and what they ask you to do. Okay, just to recap some things about odds. Standard 52 deck, the bet is placed on ace or 3. So probability of winning, there's 4 aces, 4 threes, so that would be 8 out of 52, so that's a 2 out of 13. Odds against would be 11 to 2, because there's 11 out of 13 ways to lose, 2 out of 13 to win based on the probability of winning, which would be 11 to 2 as your ratio. Okay, using that, we're going to compare the payoff odds of the company versus the actual payoff odds. So the payoff odds of the company are 5 to 1, and if you bet $20 and you cross multiply, you should end up with a $100 profit. If it would have been the odds given to you, okay, based upon the actual odds of the standard deck, then it should have been 11 over 2. So that would be you bet $2 and make 11, or bet 1 and make 5.5. Okay, if you divide by 2. But when you cross multiply this number should be higher, and you should get 110 versus 100. Where does that extra 10 go? Well, they pocket just a little bit to make sure that they make a profit in the long term. There's a lot of info today dealing with different odds pieces and different ideas of complement and at least one. You want to make sure you're looking at that for your homework. Don't wait till the last minute to do some of those homework questions, because it might be a little confusing in order to get some of those answers. And you want to make sure that you have those pieces figured out for your upcoming test. Have a good day, everyone.